Insect pests are a massive global problem, and about 10% of all the food we grow doesn't make it off the field because of them. It means about 2% of all the CO2 we produce as an entire species is just going to feeding bugs in fields. If you can catch them even a little bit earlier, you can massively reduce the amount of damage they do. And that's the problem that Spotta's solving. The normal way that people monitor for insects today is you either see the damage they do after the fact, or you have a bit of sticky paper or a plastic bucket that someone has to go and check every week or two. The core of what makes Spotta unique is that we can have a camera system that runs 24/7, 365 days a year off a single alkaline battery, and no one else can do that.
The UKRI Transforming Food Production Challenge, delivered by Innovate UK and BBSRC, supports business-led innovation to develop and test new ways of producing food that enhances the efficiency, productivity and sustainability of the agriculture sector to help realise net zero emissions by 2040. The TFP Challenge's competitions supported businesses at the early stages of developing new technologies and their adoption across the traditional agriculture sector, right through to driving business growth and scale-up through investor partnership competitions, aligning non-dilutive TFP grant funding with private equity investment.
In 2021, we were awarded a grant from Innovate UK as part of the Transforming Food Production programme, and that was matched to equity investment from a specialist VC fund called the Yield Lab. Typically, the resources available for companies like us making hardware solutions, putting them in field, we've got pods up in the mountains of Scotland and the deserts in the Middle East and 9 other countries between them. That would not have been in reach for the stage we were at. By bringing in the grant funding as well, that meant we were able to be much more ambitious, and now we've grown to nearly 20 people as a result of the project. So the way our system works fundamentally is that we have monitors that we call pods that we place in the field, typically every 100 metres or so, on a grid, and they have inside them some technology for attracting the insects. The insects move inside. Our ultra-low power vision system takes a picture. It can identify what species that insect is and whether it's a pest or not. And that information is then transmitted back to our servers, where we have models developed by our entomologists and by some of our engineers to map what that means in terms of the damage that those insects are doing, how they might spread, and helping farmers to scenario plan different treatment options of managing that. At the moment, agriculture uses about 4 million tonnes of chemical pesticide a year, and that is pretty devastating for natural wildlife, particularly other insects, of course. We've already demonstrated in some cases that we can halve chemical insecticide use. We actually want to go further than that. We think it's possible to eliminate it completely and support the transition to biological control, for example. And the net effect of that, if we're successful, will be something like a 2% reduction in global CO2 emissions, which is equivalent to taking about 100 million cars off the road. Off the back of the success of the project that we've done with Innovate UK and the investment, we've just closed another investment round actually for our next stage of growth, which will involve bringing more products to market, more different pests that we're helping with in agriculture. We've started hiring internationally now and been exporting quite significantly over the last few years. So yes, we're ready for the next stage.